Yeah, g'day guys, and welcome back to my channel. If you watched my last video, you know that this vertical head has started making some horrible noises. It kind of sounds like gold coins bouncing around in a platinum washing machine. At least I'm guessing it's going to be expensive. It sounds like a bearing noise. Anyway, let's whip this off, start trying to work out what the problem is. Now, some of you might not have seen the video I did on purchasing this old CNC machine and converting it to a modern control, so I'll leave a link up in the top right corner. Maybe you want to check that out first. First up, let's just take this cover off. I got a lot of good feedback from you guys on what the problem could be. It seems like a plurality of comments are for a broken bearing cage making that rattling noise. Probably the second most likely cause, according to the comments, was a broken bevel washer in the hydraulic drawbar system. And other thoughts were a bearing race spinning in a housing, or maybe some issue with the bevel gear drive system. Right now, unfortunately, the manual, so apart from telling you how to swing the vertical head into position and to remove it, and how to use its quill or lock it, how to adjust the pull studs. Okay, there's a hydraulic plan. Yeah, there's nothing here about how those hydraulic pull studs work or are disconnected. But I'm hoping I can just remove it in one piece. I'd really like to keep the hydraulic system closed so that I can keep using the mill as a horizontal even with this head disconnected. Obviously the other option is I disconnect here and just blank the hydraulic hose. This is free turning. I'll just remount the head briefly to use the gearbox to stop rotation and give me something to wrench against. So the gearbox is in its lowest gear and the brake's on, so that means it should be locked. Now I kind of have my doubts whether I'm going to get enough torque on it like this, but oh, look, cool. It's not that tight. Oh, and there it stops. My guess is I probably need to go up inside the spindle and unscrew that gripper, because that's probably what's stopping it from unscrewing completely at the top. Okay, looking at the instructions for adjusting the gripper, it looks like there's a screw in the middle which safeties it. And once that screw's loosened, I should be able to unscrew it. So this drawbar mechanism is basically a single acting hydraulic cylinder with a spring return. Looks like its threads are stripped. That certainly doesn't look good. Might have to get a replacement. It's weird because there doesn't appear to be any matching damage on the spindle, which is a good thing, of course. You know, taking a second look at that, I'm not that convinced that it's actually a defect. That looks way too even, like someone's machined it away, and the matching thread on the spindle's got no evidence of damage or any form of wear or debris from being cross-threaded and taking out these ones. So I actually think maybe that was done deliberately. There will be a stack of bevel washers in here to make the spring. Those springs are also consumables. They quite often crack or break or wear out, so that's something I need to consider as well. As far as I can tell, the only thing holding this head in place still is that roll pin there. So let's try knocking that out. But I'm guessing this head's still not going to come off without a fight. Let's see if I can just pull it. But I probably need a bit of leverage in there, I think. Right, can I do something with a bit of wood and a pinch bar maybe? It's kind of awkward to get in here. Right, well if I can't get this end of the arm off easily, the back end just looks like it's 3 socket head screws, so let's have a shot at that end. And pulling the head off is going to need some reggae. Right, I'm hoping it just lifts off there now. Right, what happens if I very gently lift this table up? Put some wood under it.
lower it back down to pop it back. Well, that worked. Just put a little wedge under the back. This could well be a slow process, but hey, rather a slow process than damage.
Well, I'm glad I didn't try any more force trying to pull this arm off, because there's a second fastener. Yep. Sure enough. Yep, glad I didn't force it. Mail time. Hey guys, when you're doing like maintenance work, do your health a favor and try and keep your skin from absorbing all of the hydrocarbons and grease and additives and shit. I use a barrier cream called PR88 and I just finished one, so it's time for a new one. You can tell this stuff works because at the end of the day, even if your hands are really dirty, when you go to wash them off, all the grit just falls off, doesn't get absorbed, and I assume that's good because it can't get into your bloodstream. So look after yourself, huh? I'll leave a link to this barrier cream down below. Make sure you get yourself some. And I'm not sure if the same stuff's available in America or not, but maybe I'll find one and leave a link to that as well. Anything's better than nothing, guys. All right, next up, let's just twist this around a bit. Now I'm guessing that when I remove these bolts, that the whole angle gearbox part just comes off. The whole bevel drive. Okay, looking at the mechanical drawings of this head, it looks like this doesn't come off as just one piece. There are screws between this casting and the head casting. I'd have to first extract this casting off this bearing and then unscrew 2 bolts to be able to get this next casting off with the rest of the angle gearbox. However, I'm not sure I need that. Let's turn our attention. If I take this flange off, which is secured by these Allen screws under the fan, I should be able to pull the drive mechanism out to the top and then pull the whole quill out. Let's give that a go. So how do I get to those screws there? This is obviously a nut, but it all looks too fancy to be part of that fan. Let me just take a look at schematics again. Okay, sure enough, so this nut is the one that preloads the bearings of the angle drive from the top. So I'm guessing that this is just like slipped over it. Ah yeah, sure enough. It's moving easily. There we go. Before I take this part of the angle gearbox off the top, I think I'll just swing it around and strip off the quill drive mechanism and this cover plate. It's kind of a shame that MAHO didn't do any paint prep on the bare metal parts. They just put top coat straight on, because I've got a bit of corrosion gone down under the paint, so it's now just flaking off there, unfortunately. Wonder if this comes out as a unit or I have to actually disassemble it. Okay, that came out nicely. Apart from a wee bit of corrosion on the back, it looks to be in pretty nice condition. Alright, next up, on this side we've got the quill lock. Oh wow, that's a beautiful fit. That sure is a way to do a super secure quill lock. Right, let's pull the upper bevel gear and drive off. All of these bolts feel very, very similar in force, so I'm sure they were all torqued properly and not just cranked by hand. Now, if I understand the drawing correctly,
I should be able to pull this up, which will bring both bearings of the bevel drive up with it. Luckily there's a nice lip under here. What's that feel like? Oh, so it's got what looks like ground shims, which I guess is there to set the play of the gears. So let me just mark where these come from. I'm going to guess that they're all the same thickness and therefore the alignment is not important. But until I've mic'd them to confirm that, I'll just be sure that they go back in the same place. Oh, nice. Very nice. Well, that sure came out nice and easily. These gears are lubricated externally. They get a few squirts of Kluber grease whenever I remember it. Just a quick visual inspection. I don't see anything too out of the ordinary there. Sure feels nice. These upper bevel gear drive bearings are probably also pretty dry, I imagine. Beautiful parts. Now on this side there's two more hexes. One of them is probably the range of movement stop for the quill. So let's try removing both of them. That definitely forms the stop for the range of motion of the quill. So I'm guessing that quill should probably now just fall out. Sure enough, there it goes. And there we have it. Now the thing that worries me most about the spindle is that the bottom bearings are these integral bearings. They have no separate inner and outer races. So if anything happens to them, like corrosion, it's probably going to destroy both the spindle and the housing and the bearings, which would be really expensive to repair. The upper bearings are probably just two pairs of precision angular contact bearings. Now I was kind of hoping to remove the spindle from its housing with the bearings staying on the spindle. But looking at the design, it doesn't work that way. When I extract the spindle, two pairs of angular contact bearings are going to stay in the housing and only the integral roller bearings down on the nose end will come out with the spindle. I'm guessing that's just a lock nut. When I put it back together, I don't have any specification how much preload I need. But if I try and put the nuts lining up in the identical spot on the shaft, that should hopefully get me close to that. A few of these have got like rust spots and that on them. Since MAHO didn't seem to have any qualms putting vibropening and other scratches and stuff to mark this thing, I'm just going to put a little scratch here. Directly across from the slot, because there are two quite major wear marks in the splines, and that's going to be on the bigger of the two. I'm kind of talking to myself here for when I put it back together. The only pin spanner I have is this one, and it actually fits perfectly. Yeah, as I expected, it wasn't terribly tight. Nice to see the threads are in perfect condition. They feel great. Now we have to take off the cap which preloads the outer races. Well, that was very loose. That was also very loose. And that one's totally loose. So three of them were definitely not torqued. Oh, and I've just seen here, ooh, nasty. That looks like rust. I hope that's just old grease, but I guess we'll see once we take it apart. It definitely feels like rust, but it's only on the side away from the bearing. So it looks like I might have dodged a bullet there. The specified lubricant for these bearings is Kluber F23A, which is an old spec, it doesn't exist anymore. At least I can feel there is definitely a bit of grease hanging around the bearings. I don't know whether they're still greasy in the bearings. We'll see once I get it apart.
That's greasy. Greasy. Easy.
But giving it a bit of a wipe down, you can see that this grease has aged an awful lot. I'm guessing this grease is probably nearly 40 years old. The machine's from 1985, so it was probably made, yeah, close to 40 years ago. I have no idea whether anyone's ever been in here before to re-grease them. Right, well now we get to the bit that I've been most afraid of. I don't have any disassembly instructions for the spindle. For other MAHO spindles, their recommendation now is turn the thing upside down and bash the spindle out on a piece of wood. That's good. This is actually working. So this is the scariest bit. With the first look, at least there was plenty of grease still and everything. I'll have to get in there and do a proper clean out and give that a decent inspection, but it doesn't look like an obvious massive bearing failure on the integral bearing. It's both the outer race and the inner race, at first glance, are looking pretty reasonable. Right, before I can inspect them, I'll give them a wash in white spirits in the ultrasonic bath. Now I want these bearings to go back in the same way they came out, so I'm going to make sure that I always keep them in the same alignment as they came out of that spindle. Right, now the upper bearing pairs. Oh. Well, that came out easier than I would have expected, I guess. So these bearings are made by FHE, B71207. I'm sure these will be P4 precision bearings. Once again, I want to keep the pairs together and keep the alignment as it was. This one doesn't want to come out so easily. Move smoothly in the ball lower down. And then binds up on the lip. Okay, being gentle, it did just pop out. Next we've got the inner spacer ring and the outer spacer ring, and then the second pair of bearings. So there's the stack. Right, so the integral bearings have just finished their rough cleaning. I'll give them another cleaning with fresh solvent, of course. But just to get started here, can I see any obvious damage to that cage? So there is a little bit of discoloration on the bronze of the cage, or bronze or brass or whatever it is, but so far no signs of any cracking or anything. This just spaces the rollers apart. Feels fine. Right, as I said, I will still need to do a fine cleanup on these. I got to be careful because I want so badly for these to be serviceable. I got to sort of try and put aside my my financial concern and give these a good inspection. And no obvious cracks or distortion or anything in that raceway, in that cage I mean. From what I'm seeing so far, I'll probably be putting these back in. These are pretty expensive bearings with this machined brass bearing cage, which is riveted together. I'm sure these are not easy to get. I mean, maybe DMG still has some on stock, but if they don't, it would be a nightmare getting more. There's a marking on here, which I'm guessing they do during production. -3, I'm guessing it's -3 microns, whether that's the bearing race diameter. They also put a -2 on the inside. So maybe that is the dimensions of the inner and outer race, and then they find a matching set of rollers to fit that pair of spindle and housing. Who knows? Right, out goes the dirty solvent. Just let those drip dry a little. Just sit on the lid. and then they get bagged in a Ziploc bag. Hey, looking at the bottom end of the spindle, you know what you don't see? There's really not much of a labyrinth seal there. In fact, there's really no labyrinth seal. I guess this turned surface here sort of forms a little bit of one, not much. So I'm really glad I haven't got into the habit of using compressed air to clean the machine. Probably also a good idea not to use one of those mist cooling systems for this machine. I think I'll just stick with a low pressure flood cooling, which hasn't been able to press coolant or any other contaminants up into that lower bearing. Right, so these bearings have now also had their first wash. Other than the grease, there's really no debris in there, which is good. That's the way it should be. So I'll put those back in with some clean solvent, give them a fine wash. So another whiz in the ultrasonic bath for them. So the integral bearing in a race here, it's definitely got a bit of a polishing mark on it. There's nothing I can do about this. I'll be putting it back together. Can't see that being enough damage to cause that rattling sound. There's the matching outer race, which also doesn't really strike me as having anything significant on it. It's looking pretty darn nice. Wee bit of discoloration, but you'd expect that from it having run. What about the other end? Another possible root cause was a bearing spinning, and unfortunately I do have a bit of a polished ring here on the inner race, which kind of surprises me because the inner races are normally the ones that are the tightest seat, and in this case definitely the outer races did not have a very tight seat at all. But let's take a look at them. Okay, there is some evidence that that upper bearing spun. It looks like that was probably the rattling I heard. Just one of those four bearings spun. Given the fact that the outer races should be preloaded through the cover plate and 3 of the screws on the cover plate were loose, I'm suspecting that I've found the root cause of my problem here. Okay, so this top bearing is the one that must have spun. Yeah, so what do I do about this? I can't see any damage to the phenolic cage at all. Okay, so this is just a brass wire brush wheel just to take that rust and corrosion off. Luckily that corrosion was not on a functional surface. Now, if you've watched this far, you're probably either enjoying it or you're a masochist. Either way is fine by me, but I would appreciate if you could send a link to this video to other friends of whom might enjoy it or who are also masochists. So what do I do next? I guess I have 3 options. Option 1 would be simply lube up these bearings, reassemble it all, torque this properly, and leave it at that. I guess option 2 would be replace the top bearing, keeping the rest of them, and reassembling it. The third option would be replace either the top pair of angular contact bearings or maybe even all 4 of them, although I really don't see why the other ones would need replacing. Would that bearing spinning that little bit, doing those little polish marks, be enough? Am I going to need a couple of spots of one of these bearing glues on the outer race of that top bearing to stop it rotating again? Would you use that? So what do you think you would do? Thanks very much for watching.